We're going to balance an oxidation reduction reactions, actually two different reactions. And these ones are relatively easy because notice how the magnesium goes to magnesium 2 plus. So they give us charges. So it's a little bit easier than if they just gave you, for example, an organic compound. So just by looking at this, we know the magnesium is going to change oxidation states. So we're going to come over here. We have magnesium in the solid state. That's the way that you find magnesium in nature. So the oxidation state is going to be a 0. And we see that magnesium actually going to magnesium 2 plus. Now, I'm going from 0 to a 2 plus. So this is actually losing electrons, and it loses 2 electrons right here. So I'm going to balance this little equation and put 2 electrons right there. In terms of what's happening in the rest of the reaction, this hydrogen right here, this hydrogen is a +1. The chloride is a -1. Let's see what happened on the other side. The chloride did not change oxidation state. It was a -1, and in here it's still a -1. But the hydrogen did change. The hydrogen went from a +1 to hydrogen gas. This is the way you find hydrogen in nature. So the oxidation state of this hydrogen is a 0. So let's go ahead and write down what happened to the hydrogen. So the hydrogen was a +1 right here. And it got reduced. We'll talk about that in a second. It got reduced to hydrogen 2. I am going to need 2 electrons for this. So I'm going to put them right here. That means that I need to balance this equation, so I'm going to need 2 of those hydrogens. So now I have to actually put that 2 up here because I need 2 of those protons so that they can take the 2 electrons. And I need to keep a balanced equation. So I'm going to put that I need 2 hydrogens here. Now I need to balance the chloride, so I'm going to come over here and I'm going to put a coefficient of 2 in front of the chloride ions. And that's because, again, it looked at the beginning that everything was balanced, but I have 2 hydrogens over here, so I need 2 hydrogens, and then that unbalances the chloride, so I need to rebalance the chloride. In terms of what's happening in these reactions right here, magnesium goes from 0 to +2. That's an oxidation reaction. The magnesium is getting oxidized. The hydrogen is getting reduced. It goes from a +1 to a 0. So this is a reduction reaction. One extra thing. The magnesium is getting oxidized itself, but it's causing the hydrogen to be reduced. So we're going to call the magnesium the reducing agent. The hydrogen itself is getting reduced, but it's causing the oxidation of the magnesium. So this hydrogen is an oxidizing agent. All right, so that's the answer for this. We balanced the equation. We have the electrons all balanced here, and we assign who's the oxidation and reduction agents and who's getting oxidized and who's getting reduced. Let's do that again with this one. We have cobalt and nickel. Notice nickel right here is in the solid state. That's the way you find it in nature. The oxidation state of that one would be a 0. So let's go with cobalt. Cobalt goes from 3 plus to cobalt 2. Nickel goes from 0 over here and it gets oxidized to nickel 2 plus. 0 to 2 plus, that means that the nickel got rid of 2 electrons. And now here's the problem over here. We need to have the electrons balanced. This equation, the way that they give it to us, looks balanced, but it's not balanced in terms of the electrons that I need. I know that nickel got rid of 2 electrons. So the cobalt is the one that's picking those 2 electrons. So I'm going to need 2 cobalts. And if I have 2 cobalts, 3 pluses, I'm also going to have 2 cobalts, 2 pluses. So I'm going to go to the equation and I'm going to change the coefficients on cobalt. 2 over here and 2 over here. The nickel stay the same because I have the right number of electrons. So I have 2 electrons on the left, 2 electrons on the right. In terms of what's happening to them, nickel goes from 0 to a 2 plus. So this is an oxidation reaction. The cobalt gets reduced. It goes from 3 plus to 2 plus. So this is a reduction reaction. Who's the agent for what? So the nickel itself, it's getting oxidized, but it's causing the cobalt to be reduced. So this is the reducing agent. The cobalt is getting reduced, but it's responsible for the nickel getting oxidized. So the cobalt is the oxidation agent. And that's how you work this type of problems.